Hello, everyone. Welcome to the Mindscape podcast. I'm your host, Sean Carroll. I'm presuming that a lot of Mindscape listeners are fans of, or at least have seen, Star Trek and Star Wars and various other TV shows and movie franchises where human beings have to interact with aliens. And there are obvious cinematic constraints which make it much easier to portray the aliens as more or less humanoid than as completely different kinds of organic beings. Even when you are allowing yourself some fraction of your aliens to be completely different than humans, you usually have some humanoid-looking aliens. We all know that's not supposed to be a prediction, right? They're making it easy for human actors to play the aliens as characters. As storytelling, as narrative devices, it makes perfect sense, even if we all know that the real world probably isn't like that. If there are aliens out there, they will probably look and biologically act completely different than us human beings. We don't have a good idea of what completely different means in this context, but it means something very different. That much we can say. At least we can say that it probably is something very different. There are arguments that maybe there should also be similarities, but the differences can be large. But that's about what the aliens look like and how they biologically are put together. What about how aliens think? After all, we human beings think in very specific ways. We use language, as we've talked about here on the podcast. We use math. We use science. We build technological devices. And we tend to think, once we've developed a successful way of thinking, that it's the best way of thinking, the rules of logic or mathematics or the scientific method. The idea of grammar with nouns and verbs and adjectives and adverbs. That just seems natural to us. How else could it be? So what is this space of possibilities when it comes to aliens and how they think? Today's guest is Daniel Whiteson, who is a physicist, a particle physicist, in fact, theorist at UC Irvine. He's the author of several popular books on physics and also host of a podcast with Kelly Weinersmith, previous Mindscape guest. I encourage you to check out Daniel and Kelly's Extraordinary Universe, where they talk about all sorts of individual science questions. Again, just trying to understand the world better. They're not trying to be provocative or anything like that. It's a very educational podcast. But Daniel's new book is in collaboration with Andy Warner, who is a cartoonist, and the title is Do Aliens Speak Physics? And Other Questions About Science and the Nature of Reality. The idea is, let's let our minds roam a little bit. Let's see, can we break out of our presuppositions about how thinking works, how science works? Are there other ways to understand the world? Are there other ways to live and maybe even to be technologically adept without understanding the world in exactly the way we do? Would aliens invent the same kinds of physics, the same kinds of math that we do here on Earth? The answer, of course, is that we don't know, but it's extremely important if we're going to not be too startled when we eventually do meet the aliens to think about all those different possibilities and to think long and hard, what are the ways where aliens could be not only looking very different than us, then thinking in dramatically different ways. So let's go. Daniel Whiteson, welcome to the Mindscape podcast.
Thanks very much for having me on to talk about such a fun and nutty topic.
Well, I admire the fact that as a fellow author of physics books and a fellow podcaster, you were able to come up with an angle to talk about physics and science and things that seems new and fresh to me. With the talk to there's been a lot of books about physics, and it's hard to prevent yourself from saying the same thing over and over again. But
I have to give credit to that for my 14-year-old son at the time, actually. I pitched him a book about, is physics universal or is it just something we're making up in our minds? It's sort of fundamental philosophical question that I really wanted to write about. And he was like, nah, boring. and he was just reading a book about aliens. So I came back and was like, okay, what about when aliens come? Can we talk to them about science? Just sort of make it concrete. And he was like, that sounds like a fun book.
Of course, it's
And
exactly
so
the same book.
it's the same book, exactly. And that's how I pitched it to the publishers, et cetera,
Yeah.
et cetera. So thanks to my 14-year-old for being brave enough to tell me that my idea sounded boring to him. But
My impression,
yes, in the end, I read the book anyway.
I don't have children. My impression is 14-year-olds are pretty brave in telling their parents when they think that they're wrong. So, but so you're telling me that, the science fiction shows that I've seen and movies where I meet aliens and there's a universal translator that just lets me talk to them right away. You're telling me that's not on the horizon, that we're not going to develop that?
I think that would be fascinating, and I would love it if it were true. I think it's going to be challenging. I think the classic alien contact scenario that you see like in the movie Contact or in so many situations where the aliens are not here, but we just get a message from them. Mm-hmm. I think that's much more difficult to unravel than a lot of people expect. And that's sort of the whole message of the book is like, this sounds like fun and we'd love for it to be easy, but it's going to be a lot trickier than you might think so. And in the case of like interstellar communication, the problem is like, we don't know what kind of message we're looking for. We don't know whether we've translated it correctly. We have no idea essentially what the context is, and unless the aliens show up and they're like standing on Earth and we can like point at a donut and say, this is a donut, and we can repeat it, et cetera. Yeah. Unless we have a physical context together, I think that's almost hopeless. I think if they do show up, we have a pretty good chance of being able to communicate some basics and build from there.
Was it Voyager that had the golden record on it with the pictures of human beings and so forth? And I've seen that, and I know there's supposed to be a lot of information contained there, but I was skeptical that I would be able to decode really what was being said, and I'm a fellow human being, so I think that the obstacles are real.
Yeah, and I think there's a lot of wonderful optimism in, Carl Sagan and Frank Drake's approach there. The Pioneer plaque, it has these little codes for what a hydrogen atom is, and it defines one, in a unit of time and all this stuff. And it's wonderful. And it's an expression of like, hey, we're the kind of nerds that like to think about this. And if you are too, then we have something in common. And that's great. But I think practically speaking, if aliens get that thing, there's no chance that they're going to, even if they recognize it as, a remnant from a civilized culture, if their version of Avi Loeb, calls it out and writes a book about it, then the chances that they could decode it are almost null because of the cultural assumptions built in there. And I actually showed the Pioneer plaque to a bunch of grad students here. You see, I did a little experiment. I was like, okay, they're old enough to not have seen it before. Yep. So it was fresh. And I was like, what do you think this is? And they spent an hour. They made no progress. They had good guesses, but they got nowhere close. And as you say, they are humans. Yeah. They grew up in the same context. They're the easiest target, but it's just so much more difficult. And that's one reason I want to write this book, is to try to like exercise my mind and try to push past those boundaries and think, what else could we be making assumptions about? Where else in our physics could we be biased by our humanity, thinking about things in only one way that we could be surprised about when aliens come? And not just like, how does their language work, but like the fundamental explanations for the universe.
So I know that this is not what your book is mostly about, but it does make sense, I think, to talk about what the aliens might be like, right? Yeah. Just before we get to how they think about science or math or whatever. Of course, we don't know, but how broad should we let our imaginations run? Do we think that aliens are planet-based? I know that there was the famous story about the alien that was living in an interstellar nebula, right? Was it who was it? Stapleton? I forget which first. Fred Hoyle wrote a book about that, I think. But anyway, so what assumptions do you think are reasonable to imagine? What gives some tangibility to the aliens we're imagining talking to?
I think that we should think as broadly as we can, frankly, because the more broadly we think, the greater the possibility we have to discover them. If you take the other direction, say like, we're only going to look for humans and we're only going to look for human technosignatures, then obviously you're going to miss stuff, because it's almost certainly not true that there are other humans. Or even in the perturbation theory version of Star Trek, where they're like humans with fuzzy foreheads, right, or whatever, it's almost impossible for that to be the case. So the broader you look, the more likely you are to find stuff. And that's honestly one reason why I wrote this book, is to try to think more broadly. And, biologists have already done that. Biologists have have thought like, well, do you have to have water to have life? Like, what about ammonia? And the chemistry of ammonia is promising. And yeah, it stinks, but, maybe aliens think that, that water smells funny. Or, do you have to have carbon to have life? And so the biologists are way ahead of the physicists in this point of view in terms of thinking beyond the Earth box and trying to interrogate our assumptions and from our N=1 example to wonder what alien life should be like. And so they've done a great job, I think. And I think what we need to do is follow up with that and think, well, what if you are one of those aliens? What if instead of walking on the surface, you live in an ocean under a frozen crust? Or what if you do live in an atmosphere of a star? Or, what if you are some weird alien where the boundaries between your bodies are not even well defined? And does that mean that that counting and integers are not a natural thing for you? And how does that lead you differently to develop mathematics and physics? So I think that there's a lot of work to be done there that frankly has been done by philosophers. Philosophers dig into these questions deeply. Physicists are the ones who are like very confident. I mean, I spoke to a string theorist who said, I'm sure aliens do string theory. And if I walk down the hallways of my department here, I would bet you that 95% of folks would think aliens do quantum field theory in some way. That, when they show up, we'll be at the board within 20 minutes talking about Lagrangians.
Well, it's fascinating to me because I've had biologists on the program with very different opinions about the role of sort of contingency and randomness in biological evolution versus convergence and constraints that come from physics. I mean, I have no opinion, but I can imagine an argument.
You have no opinion? I
have no opinion about some things. I have credences on a set of different propositions, but I can imagine that we will eventually realize like, upright bipedal organisms with brains on the top just make sense at the end of the day. But I can also imagine, like you say, we don't even have individuals, right? Yeah. We don't have anything that you would call consciousness in these organisms. So I actually am pretty open-minded about that.
Well, the other thing to ask yourself is, which would you prefer? Like on one hand, it would be fascinating to meet aliens and discover, they are bipedal and they have eyes in the front of their head. And it turns out that the way we are is useful and important and the universe just sort of ends up that way. But that's sort of like, traveling and going to another country and discovering, the coffee is Starbucks. Isn't it much more fun when you're like, what? They put the grounds in the coffee and there's no milk in it? And like, that's the point of traveling. So if aliens show up and they're doing quantum field theory, like that's kind of a big yawn. I mean, I would love to fast forward our progress in quantum field theory, and I'm sure we're doing that without the aliens, despite all the controversy here online. We don't need the aliens, but it would be awesome to get 1,000 years jump forward. But it would be so much more interesting if they show up and they're like, what? That is not the way to think about the universe. Fields? No. We got this other thing called Schmields, which makes much more sense. And all the problems you've been having, the infinities and the struggles and the confusion are because you approach this the wrong way. I'm struck by what David Tong said on your program a few episodes ago. He says, everything looks like quantum field theory because it's the only thing we can do.
Well, I love the fact that you've already decided that certain kinds of aliens are just going to be boring. So you're already
relatively. I'm excited for
discovery in human history. It's like, it could have been better.
Look, if they show up and they offer you Starbucks, you're going to be a little bored with that, right?
I would be a little bit bored with that. But yeah, I mean, how biologists can be open-minded and they ask about substrates and they ask about water and carbon and things like that. How much have they thought about, is it possible to be technologically advanced thinking without having individuals, right? With being a group mind or something like that. I mean, I know that various animals, even unicellular organisms, sort of work together socially in different ways. Is that one of the obstacles we might face when we eventually meet the aliens?
It certainly is. I mean, the structure of their bodies is going to influence the sort of evolutionary structure, the situation in which they evolve, and so therefore how their minds work. There's a really interesting argument by Marvin Minsky who suggests that, if you start with counting and addition, that you can work up from there to basically all of human thought. And he even does a bunch of cool experiments where he runs a bunch of random Turing machines and discovers that most of them do nothing interesting. They stop, they delete themselves. But the ones that do anything interesting are the ones that add something. And so maybe adding is the fundamental element of thought. But, this is sort of in an environment where, again, you have discrete bodies and you do have the same foundations of mathematics. And so it could be that having, a hive mind or bodies that, flow and swap leads to a different kind of fundamental thinking, which leads to, again, a different kind of physics. It certainly could be. And one thing that I really enjoyed thinking about in the book is, what if aliens perceive the universe differently? They have a different set of senses, and we see and we hear and we think. And I read Ed Young's wonderful book about animal perception, but something that I was hoping to see in that book that I didn't see enough of was, what is it like to be an octopus or a spider, right? We know that animals on Earth perceive the universe differently, but we don't know what it's like to think about the universe as an octopus. And the crucial thing is that, we translate the universe back into things we find intuitive. So this is why we have this struggle with the particle wave duality, because we're looking at photons and trying to describe them in terms of things that make sense to us. So it's kind of like this wavy math. It's kind of like this particle math. You and I know it's neither of those things. It's something new and weird that we're trying desperately to describe in terms of intuitive concepts. And I think that there's a connection between the way we perceive the universe and the concepts we find intuitive. And if we had a different set of senses, it's not just that we might see different parts of the universe, like higher frequency light or lower frequency light, but that we might perceive it, but that we might accept different answers as natural and sensible. So for example, say you had aliens that were super duper microscopic and they interacted with individual photons, right? Yes, the human eye can technically see one photon, but say you could interact with photons. You're like a quantum object. You can interact with them without collapsing them somehow. So you get to experience a superimposition. Maybe for those folks, quantum mechanics is easy. It's not a struggle. So it's interesting to think about how aliens might perceive the universe, which structures how they might think about the universe, which affects the kinds of explanations they might accept about the universe and the things that they study and work on and struggle with.
Do you know about George Gamoव's Mr. Tompkins books?
Absolutely.
Where he just says, what if, the speed of light were a few miles an hour, or what if H bar were really big? And you live in a very different world. And like you say, then your progression of understanding the world in different ways might be very different.
Yeah, I love that he wrote poems in those books, little songs. I thought that was very brave.
It was brave. He was a brilliant physicist who had trouble getting permanent employment. So maybe the bravery was a little bit counterproductive. But
I love the general point that he makes, that we experience a certain slice of the universe and we find that intuitive. And that's why we struggle with relativity. And if we evolved in a situation where we were going half the speed of light relative to each other all the time, we're 90%, then those things wouldn't be counterintuitive. And that's not just we color shift the James Webb so that it looks, like something that we can see with our eyeballs. It affects the kind of answers we look for and the way we frame them. There's some point at which you stop asking questions when you're okay, that makes sense. And that point is determined by what makes sense to you. Yeah, that point might be different, exactly, about different topics.
So if we think about the senses that human beings have, right? Vision, hearing, I'm gonna forget all the senses. Touch, taste, smell, right? What are your credences for aliens having these kinds of senses? I think that sight and touch sound pretty inevitable to me, but I might be debatable about the others.
Yeah, well, it's fascinating and it's hard to say, but one thing we can do is look back into the evolution of these senses here on Earth and say, how quickly did this arise? Is this something which instantly arose and arose in many different ways and therefore is likely to pop up in other places? Or is this something which only recently developed, like intelligence? And so you might ask, like, maybe it's unusual. And it's fascinating that it turns out that senses like hearing, which seem pretty fundamental, evolved fairly recently, basically connected to the development of multicellular organisms. And there are folks out there, evolutionary biologists, who suggest basically once things got big enough to make noise and they started chomping on each other, then it became very useful to be able to hear, is somebody about to chomp on me? Is there somebody there I can chomp on to have lunch? Mm-hmm. And because these two things arose sort of at the same time, you can make that argument that that if you're big enough, you're going to make noise, then probably somebody's going to learn to listen to you. And we can dig deeper. We can ask, like, are the fundamental mechanisms of those things the same across all of hearing? Because, for example, here on Earth, flight has evolved separately and differently according to unique paths, right? So it's not hard to argue that an alien planet, somebody might figure out how to get aloft because we've done it several different ways here. And on Earth, we have like two different kinds of ears, basically. But fundamentally, the biochemistry of it is similar. And so there might be a single origin for hearing on Earth, a moment when like people started, listening to the doorbell. And so it seems very likely, but it depends a lot on the environment and, the size of these creatures. So again, it's asking how similar is our situation to theirs. If they're evolving on a similar planet in similar conditions, similar temperature and chemistry, probably they're going to develop hearing. But, that's the interesting part. The more different they are, the more different their senses might be.
You and I are both physicists, so we probably have answers to this question. But is it possible that the aliens would be able to sense things that are beyond our ability to sense, even with technology?
Beyond our ability with technology? You mean like could aliens
like beyond the standard model of
matter?
particle physics? Do you think, beyond, crudely, biologically, we're basically dealing with electromagnetism and atoms, right? That's what we're sensitive to. Could they detect neutrinos, gravitational waves? Let's help the audience out here.
Yeah, so it's fun to think about that because the world, the universe is filled with stuff that we do not have senses for, right? Like neutrinos pass through our body at the rate of zillions per centimeter squared per second because the sun is a huge factory of neutrinos. And we know that the matter universe is dominated by something which is invisible to all of our senses, that feels only gravity. That's dark matter. And so it's tempting to imagine aliens that can sense those things because they would see a very different universe. And boy, maybe they know where the dark matter is and they can tell us, right? I would love that. But it's also kind of hard to come up with an evolutionary story where that makes any sense. Like imagine what it would take to sense neutrinos. Yes, there are lots of neutrinos out there. The way that there are lots of photons out there, and we figured out how to sense photons so we could see our lunch and avoid being somebody else's lunch. But the problem with neutrinos is that they hardly interact with us. They pass through the Earth mostly without interacting. And so in order to have something that senses neutrinos, you need a massive organ, right? You need not just eyeballs, you need eyeballs the size of Jupiter, right? Or you need some sort of new physics, something crazy, some new way to interact with neutrinos that we can't imagine. Maybe there's some exotic matter out there that interacts with some new force, but you got to pile speculation on top of speculation on top of speculation. And if that existed, I think we would have seen it in our experiments or in astrophysics or something. So yeah, if you're going to sense neutrinos, you need Jupiter-sized eyeballs, and it's hard to imagine that that's worth it evolutionarily or how that develops. So I think that's pretty unlikely. And the same for dark matter, right? Dark matter is everywhere, and so you think that might be useful, but it doesn't interact with us except for gravitationally, and gravity is the weakest force by tens of orders of magnitude. And so, other than sensing which way is down, it's not really that useful to even have a gravitational sense. So detecting like a fairly smooth distribution of dark matter through the universe would be awesome for physicists, but not very helpful for our ancestors. So it's not easy to come up with a story where aliens have senses for neutrinos or for dark matters or gravitational waves or gravitons or anything like that.
So that's
but,
good.
I hope they surprise us. I hope they prove me wrong when they show up.
That would be great. But it's a good example of how we can be very open-minded biologically, but at some point the laws of physics kick in, and the aliens probably are also going to have to deal with electricity, magnetism, and atoms, mostly just like we do.
Yeah, exactly. And to answer an earlier question, like, we're more likely to discover those who are. Like, maybe there are aliens out there that exist as weird informational perturbations of gravitons or something beyond our capacity to even imagine. But it's also very unlikely we're ever going to have a conversation with those aliens. We might just pass through each other for billions of years and not even notice.
They might be in the room with you right now, Daniel.
Yeah, exactly. I mean, if you're gonna let your imagination run wild, the denominator for this equation is literally infinite. So there's no limit to the kinds of aliens you can dream up.
So there are some constraints from physics, but there's a lot of room to play. What about some things that we take for granted? Like, we take language for granted. I just did a great podcast with Philip Pettit, who is a philosopher, about he puts language, the capacity for language, at the center of really who we are as human beings, up to including morality and law and things like that. What is your judgment about, would aliens have something called language? Would it have grammar? Would there be nouns and verbs? Or is it another thing where we can just say, who knows, it could be anything?
Well, I actually got to ask Noam Chomsky this question because I was like, who thinks about language and might be willing to talk about aliens? And he's famous for like actually answering his emails. Yeah. And so I asked him, and he said he was fairly confident, I think based on Minsky's work, that aliens probably do arithmetic and that you could communicate with them via arithmetic and build on that using Turing machines, and ... you have language.
Right.
But there again are a lot of assumptions there that aliens have that sort of mathematical structure. I talked to philosophers of mathematics here at UC Irvine. Penny Maddy is a well-known one, about like, how likely is it that aliens count, right? Back to the same question of arithmetic. And, she pointed out that it's that even humans count in different ways, and that the structure of our language affects the way that we communicate. That the concept of infinity varies. For some people, you might think like, for some languages, you might reflect things as like 1, 2, 3, and then basically infinity, right? In other languages, you naturally count up to higher numbers. Or, in Japanese, for example, there are different categories of counting. You might look at stuff on a table and say, oh, yeah, there's 7 things there. But to a Japanese person, they might categorize them based on their shapes and say, oh, well, there's 3 long things and 4 flat things. And it doesn't make sense for them to group these things fundamentally. So, I'm dodging a little bit your question on language, but I think at the core of it really is whether they have these sort of arithmetic primitives in their minds. And if so, then I think, yes, they probably will have language and grammar and communicate with each other. But even if they have language, that doesn't necessarily make it easy to decode, easy to break it apart, to translate it into concepts that make sense for us.
Could you actually go into a little bit more detail about that connection between an arithmetic capacity and a language capacity? I think the person on the street, those sound different.
Yeah. And so it goes back to this question of like, how would you build up a communication system? Say you meet the aliens and you figure out how to talk about numbers. So you have an apple, you have 2 apples, you have 3 apples. You somehow, chicken scratching on the ground, figure out how to communicate concepts of numbers to the aliens. How do you go from there to like talking about Lagrangians on the board? And so the idea is basically that you write short computer programs. And that's what a Turing machine is. A Turing machine is like an abstract concept of what is the simplest possible computer. And if you can do it on a Turing machine, you can do it on a MacBook or whatever, just faster. And so Turing machines are a helpful way to just think about like, what can you do with a computer? And Turing machines can do that. They can like write or read from a tape, and they can change what's on a tape. And so they have these arithmetic primitives in them. You can read something in, you can write something out, you can count. And so you can go from arithmetic to Turing machines, and then from Turing machines, you can use those essentially to write algorithms. And the argument is that effectively basic algorithms are a good way to start communicating more complex concepts. And it's hard to go from there to like, hey, I thought the second Avatar movie was better than the first.
Nobody thought that.
Well, maybe the aliens did, right? That's all I'd be keeping up in mind, Sean. But that's sort of the thread of the argument in that direction.
I see. Is there, I don't know if I've ever heard it speculated that arithmetic, as a matter of historical fact, came before language use and was a bridge to it. But it does make some kind of sense. Is there anthropological evidence in favor of this? Do we have any reason to think it?
No, I don't know that it did. And yeah. I'm not trying to argue that it did. It's sort of this funny thing where we reverse engineer things conceptually long after we've used them. In the same way that like this concept that arithmetic is at the foundation of all of mathematics is something that only started getting put together 150 years ago.
Right.
And it's nonsense to say like, well, nobody's adding numbers, 2,000 years ago. Of course people were, and we have evidence that people were. But in terms of like systematizing the concept, the category of ideas, what builds on what do you need to do in what order, which you might find useful if you're meeting an alien species and trying to match up your category of ideas. That's something we only sort of got organized 150 years ago. It's sort of like, somebody who's in the kitchen, who's a brilliant chef, but it's a disaster and you can't follow what they're doing at all, but they're making beautiful souffles versus, somebody who's like figured out all the chemistry of cooking and understands exactly what you need to learn in what order. That's something you can do afterwards when you've discovered how to make souffles. You can reverse engineer how to teach people to do it. So I'm not suggesting that math predated language in human evolution. I don't know that it did. It'd be amazing to discover that. But I think in terms of how we talk to the aliens, that's the order we need to go for it to follow logically.
No, yeah. So I see what you're saying now, but I think you should suggest that. I think that people should test this out. I'm now very, very invested in the question of whether or not math, arithmetic, because you can see how maybe you wanted to count things, right? And that was actually easier to do. Like in some sense, the abstraction of a number system is easier than the abstraction of an alphabet, right? Or even the idea of words. So, that's a good hypothesis. Good conjecture, I guess, as we say in our field.
But it also touches on something else I really enjoy thinking about, which is how things might have gone differently in our history. Like there's the evolutionary history of could we develop language before music, before math, and how do those things all relate? But what about just like the history of discoveries? If you are like me, are a fan of the game Civilization, then you tend to start thinking about, discoveries as having a natural order. You discover this, then you discover that, and this unlocks this, and this unlocks that. And we think about our history as the natural order because it's the way we did it. But it's also filled with examples of cases where, wow, we could have discovered that a long time, much earlier. Like, why didn't we figure that out sooner? Which suggests that like there could be discoveries we could make right now that in 100 years people would be like, geez, what was Daniel even doing? Why was he writing silly alien books instead of figuring out this thing, X, Y, Z, right? And if we make those discoveries in a different order, like aliens might, how does that affect the discovery? How does that affect the development of our understanding of physics? I heard you say on a podcast once, which inspired me, about how we might have discovered quantum mechanics 100 years earlier, and how, essentially baby Einstein might have grown up in an environment marinated in quantum mechanics. And who knows what theory of relativity he would have developed? Would he still have gone for a classical one? Would he have found a way to develop quantum gravity? Would he have given up? And not even done it because this is useless because it only works classically, right? So like the random sequence of events that leads to our history of science being the one that it does affects a lot that what we figured out and where we are sort of along that path. And aliens could have a completely different random history. Even humans, if you run the human experiment like 1 million times, how many times do you get science where we are today, where people are arguing about Lagrangians? Is it almost every time? Is it almost never? Like, I wish I knew the answer to that question, even just aliens aside.
I do want to get to that question, but I can't let go of some language questions first. Like,
Okay.
we're thinking, even in the Star Trek, Star Wars versions of aliens, not only do they look kind of human, but they communicate by speech, by
Yeah.
literally making sounds, right? And maybe you can imagine ones that make symbols, like in Arrival or whatever. But how crazy can we get when it comes to modes of communication? I can certainly imagine different organisms communicating with sort of direct electrical fields or shocks or something like that. Is it possible within the laws of physics to imagine something like telepathy?
I mean, telepathy is not that much of a reach because, our brains operate on electrical signals. And the fact that it's hard to communicate brain to brain is because we have all these layers of insulator. And you can imagine an organism that has some exposed nerves that allows you a more direct conduits, or where you briefly have a brain to brain interface, where you wouldn't necessarily need to translate your thoughts from your internal representation into some symbols, right? Whether those symbols are spoken or written or sprayed out in pheromones or, or danced out on the floor or whatever. And that could be a completely different way to communicate. And that's something we might experience, if Elon Musk has his way and we have these brain-computer interfaces, well, we know how to interface computers very naturally. And so we could develop much more intuitive ways to communicate brain to brain, which, maybe Elon is just preparing us for meeting the aliens. But we could learn something about the natural language of thought. And I agree with you that writing and speaking is thinking in some way, but maybe that's just because I'm a writer and you're a writer and we're podcasters, and but it certainly could be that there's a more fundamental language of thought that we discover when we make these kinds of connections. So I think it is possible for aliens to have different modes of communication that aren't so arbitrarily symbolic.
Right. Well, when I called it telepathy, that was, purposefully provocative because it sounds a little crazy. But if you just called it radio, that's possible. And I guess the question then is, could we imagine an evolutionary pathway by which biological organisms develop radio communication, maybe even instead of or before verbal communication?
I mean, it's not too hard to imagine because we have all the pieces, right?
Yeah.
What do you need to generate a radio wave? You just need electrons you move and oscillate, right? And what do you need to receive a radio wave? Just electrons that can be moved and oscillated. I mean, those are what antennae are. Yeah. And we've already seen on Earth animals that have the capacity to generate very strong electrical signals and to sense them. So there's no principle there necessarily, but I wonder if that might be a barrier to developing intelligence and technology. I mean, I live with teenagers. I'm grateful that I can't hear what they're thinking all the time. And, there's a lot of speculation that the development of intelligence comes from essentially needing to solve the social problem. Like, how do I navigate this complex world in which I have to work with people to bring down a mammoth, and I have to not piss them off and be, the one voted off the island when there's not enough food for the winter, et cetera, et cetera. That's a hard problem to solve. And you see, dogs are smart and wolves are smart because they also solve that problem. And so it might be that if you operate as a single pack, you don't develop the same sort of, modeling of other people's minds, which helps us model our own mind, which maybe helps us model the universe. And I am not a philosopher of consciousness or language, but I can see an argument there that being distinct is necessary for developing these sort of ways of thinking.
Yeah, I love that thought because it does speak to the path dependence of how we get to our technological society right now. It's an example of imagining how if we got better at something, we could sort of fall into a happy minimum in the fitness landscape and just sort of exist there and therefore miss out on an even better place of the fitness landscape because there was no pressure to go there. So maybe we were forced to develop thinking and symbolic manipulation and therefore science and technology by the fact that we don't have radios in our heads.
Yeah, exactly. And I always like to flip that around and imagine, well, in what ways have we had it too easy? Are there more challenges of which, if we had had to learn to overcome them, we could be like super intelligent at this point, or just think differently about the world and find different problems easy and hard? It's the frustrating thing about the n=1 example, right? Just seeing this one. This is what gets me thinking about aliens. Just to have an n=2 or an n=3 would be incredible. Just one more data point will tell you how unusual are you. It's like rolling a 1,000,000-sided die and getting a 7, and you're like, wow, that's a weird number, right? Like, how unusual is that?
I'd like to roll it again and see if this die is actually fair, right?
Exactly. Let us roll it one more time, please, universe.
And maybe that's a similar situation as I was going to bring up with, underwater life. Like if I can easily imagine planets where life starts, which are all water, all ocean, right? We're in this weird zone where we have same order of magnitude of land and water on the surface of our planet. But you could imagine very successful life forms on water that never developed what you and I think of as technology because hands are not very useful in that environment.
Yeah, or life even in our solar system, right? Like in the oceans of some of those moons around Jupiter and Saturn. And they could be swimming around in the dark, not even aware that there is a universe out there, right? And maybe they don't care. Maybe, right? That's the other thing is like the basic question, the basic thing we assume in this scenario is that other aliens are trying to figure out the universe. Maybe that's just a human thing. Maybe that for some reason we're desperate to understand and to develop models and to figure it all out and to smoke banana peels and talk to each other about what it means. And maybe we're the weird ones in that category.
Well, we didn't talk about the Fermi Paradox and why we haven't detected the aliens yet. Is this to you a very plausible reason why we haven't found aliens yet? That maybe intelligent societies, life forms develop all the time, but they just don't go exploring because their environment doesn't nudge them in that direction?
I think my favorite answer to the Fermi Paradox, like if the universe is so old and the galaxy is not that big compared to the scale of the universe and filled with planets, why haven't we heard from anybody or met anybody? I think my favorite category of answer to that is, of course, going to be aliens are much more alien than we expect. And maybe there are lots of them out there, but the distribution is really broad. And so maybe they're not communicating with us the way we expect, or they're not communicating at all because they don't care, they're not interested, or they look very different. We're not listening to the right kinds of signals. My suspicion is that the denominator of the possibilities is so much bigger than we're imagining, that we don't know what to look for, or messages have arrived and we just haven't even heard them. Or there's the famous wow signal from the 70s, which like nobody's ever explained and nobody can decode because what could you do with that thing? It's just like one bump. And so, yeah, I think it's possible that civilizations out there, they could even be technological without being scientific, right? They could be fantastically advanced in terms of the things they can do with their universe, but they don't necessarily have to have a little population of their society that sits around and wonders why, and how does this work this way? And why is it if you leave milk out, it turns into cheese and all this kind of stuff, right? And obviously we have found that if you do that, it rapidly advances your ability to manipulate the world and to develop technology. And it's a lot of fun too. But we also, for a long time, weren't doing that, right? Humans were developing technology and fermenting cheese and bread and developing cool swords without ever really understanding why that worked and how it worked fundamentally. So it's not too hard to imagine, civilizations out there that are technological and even in ways we might consider advanced, but aren't doing science and don't care about what our thoughts are about, what makes a good Lagrangian.
Well, let's dig into this in more detail, because you've already mentioned the idea that math could either be different or mean different things to aliens. They might care about different things. They might count differently. So I'm just going to take the devil's advocate point of view here. Like, Really? You think that aliens won't count the same way as us? I mean, I can imagine at the higher levels of math, there's lots of different structures, lots of different axiomatic choices you could make. Maybe aliens feel differently about the axiom of choice or the continuum hypothesis than we do. But I bet they have arithmetic that is more or less the same. What do you think?
It would be amazing, but it would be cool if they did, but I think it would be much more amazing if they didn't. And so I mean, my natural hunch is, yeah, of course, because that's the way we see the universe and it makes so much sense to us. And because the universe feels so mathematical.
Right.
I mean, I remember this moment as an undergrad taking quantum mechanics and seeing, the precision predictions and measurements of all these quantities and coming on my own to this feeling like, oh my gosh, the universe isn't just described mathematically. It is mathematical. Like this is the source code, man. Right. And everybody has that experience when you're in awe of the power of mathematics. And there's lots of good arguments for it beyond that, like there are examples like of Maxwell, deducing the existence of the displacement current just by looking at the symmetry of the equations and noticing a hole, right? Or there's Higgs feeling like, wow, this would make a lot more sense if there were one more piece here mathematically, right? And, there's mathematicians goofing off with groups for 100 years or so before we discovered, oh, this is a fundamental representation of the way particles work. There's lots of examples that persuade you that math really is fundamental to the universe. But you asked, do aliens have to use it? And I read this fascinating book by Hartree Field called Science Without Numbers. And he makes a really interesting argument that a lot of the mathematics we use in our theories are sort of intermediate steps we're storing in our heads. A great example are fields. Maxwell's equations famously in terms of fields, and quantum field theory is all about fields. And people think about fields as the fundamental element of the universe. But when do you see a field, right? Can you interact directly with a field, right? In the end, we deduce fields are there because of what they do to particles. And so you might ask, well, how do we know fields are real in the sense that, they're there when we don't look at them, aliens would discover them also. And so he developed this whole argument that you don't need numbers in science at all. The fields are just a way to hang numbers in space. And it's an intermediate step that you don't really need. And as an exercise, he went through and developed a theory of gravity, so Newtonian, not general relativity, Newtonian gravity without any numbers at all. It builds these relationships into space, the distances between things are greater or smaller, this kind of stuff without any numbers. And it's not a great theory. It's not a beautiful theory. It's not a very useful theory, right? He doesn't argue that mathematics isn't helpful. It's just at a point that you could do this without numbers. And so maybe numbers are a shortcut. They're a way that we think. They reflect something about the way our brains work. They're handy, but they're not fundamental. And that means that maybe aliens would also discover them, be wow, yeah, numbers sure are useful. Or maybe they would find something else which is much more useful, and they would laugh behind their tentacles at our silly little numbers.
I actually, despite my rhetoric prior to that, I think you're probably right. I mean, I think that probably I'm going to guess, if I had to make a bet, that the aliens do use numbers, but it's very, very hard for us to take ourselves out of the mindset where numbers exist. And, to us, numbers are the most obvious thing in the world. But yeah, given the many, many different ways that math could develop, even if the aliens do have math, it might not be something that we recognize at all. I do think that's true.
I used to think it was obvious that numbers are a thing, but I've been watching my friends teach their 2-year-old to count. And there's an abstraction there. They point at things and they go 1, 2, 3, 4 apples. And she will go 1, 2, 3, 4, 5, 6, 7, 8. She will recount the apples over and over again, not understanding that the labels are supposed to be unique. And that's that's a basic concept in numbers here that she needs to learn. They need to teach her. Right? You've used that one up. You can't recount that apple. And that makes me wonder, are numbers real? And I read some fascinating books about the philosophy of mathematics, and boy, it sure is hard to say anything concretely. One of my favorite questions that you discover when you dig into this is, where are numbers? Right? If numbers are real, if they're part of the universe and not part of our minds, most of the things we think of as in the universe have a place in the universe. Here's a proton. There's an electron. The field is here. Where are numbers? It's a question that makes no sense, but the fact that it makes no sense is revealing, right? Because well, they're not anywhere. They're just sort of like things. Are they like souls or minds? Are we talking about a duality here? It starts to get messy very quickly if you just want to assume that numbers are fundamental to the universe. And to me, that's a clue. It's a clue that smells like, there's a bunch of assumptions we're making here and cultural biases and the kind of things that will become obvious when the aliens come and they got their own way of doing things.
Well, speaking of which, not just math, but science, we can have the same conversation about. Science as a method, right? As the idea that we formulate hypotheses and then we test them against empirical data. Once again, I'm going to confess to a bias that's probably what aliens do also, but you've written a book about this.
That's just because you're paid to do science, Sean.
Exactly. I'm just part of the science industrial complex. That's what pays for my Ferrari. Yeah. But what else could it be? Trial and error? How should we broaden our minds about how the aliens could be thinking about these things?
Yeah, it's really hard to do, but again, it's instructive to look at our history and think, well, how long have we been doing science? And, there's this story people tell about how there's this moment of inspiration, they give credit to Galileo, to Francis Bacon, essentially some white dude a couple hundred years ago decided to do experiments rather than just think about stuff the way the Greeks did. And, that's a cute story and it's compelling, but it's a little bit more complicated.
Yes.
If you dig back, you see that the Greeks were doing little experiments and, obviously all around the world, people were testing stuff out. And so there's this gradual development of science. And so what we call science is a little bit fuzzy to define. And that's there's books and books written about what do you even mean when you say science? And that's sort of a joke, anything in philosophy starts with, well, what do you mean when you say bananas, right? But it's fair because what we're doing here is digging into the foundation. And so when the aliens show up, do we expect them to be doing science the way Galileo did it, the way we do it? Do they do simulations? We have this whole new branch of science, not just thinking about things and not just doing things, but calculating things in computers and simulating them. It's a new way to compare, another idea we have for developing these models. Maybe what we call science is very primitive compared to what aliens do. And so the easy answer is just to gesture at the abstract and say, perhaps aliens who've been doing this for 1 billion years longer than we have continued to evolve their method the way ours has, right? It'd be ridiculous to imagine, okay, well, we figured out science and we're just going to keep the method the same for the next 1 million years and not make any advancements when the advancements have been fairly recent. And so it's not hard to extrapolate and say there's something there in the future that's going to let us figure stuff out more effectively or more crisply or, just a lot more fun. I don't know. Or, more productively. So there might be future developments in science that the aliens, they're so different from the way we do it that you can't even compare them. But yeah, it seems likely that they're going to do some kind of methodological building of a model that explains what's happening so you can predict experiments and tweak it. It seems very basic.
This is going to be once again my bias showing, but I find it hard to imagine that we could get a rocket to the moon without some theory of gravity. But maybe I could imagine building a computer just by playing around with electromagnetic phenomena and poking them through things, but maybe not. I don't know. I mean, what is because you've written the book once again. How much does the theoretical side of science really matter versus sort of a practical? If I probe something in a certain way, it responds in this particular fashion.
Yeah, I think it's certainly an accelerator. I think theorists are useful, obviously.
Good.
But I'm not sure it's absolutely necessary. So one of the things I did in the book to try to make these ideas less philosophical and more concrete is to come up with concrete hypothetical scenarios where the aliens could be different in some crucial aspect. And this is the one I really wanted to think about. I wanted to imagine a scenario where aliens show up here on Earth, so they've somehow solved the interstellar transport problem. They've developed wormholes or warp drives, but they don't know how they work. right? They've just sort of like stumbled or intuited their way into it. The way that we developed fermentation and swords and all sorts of technology without, fundamentally understanding the science beneath them. And so the way I was thinking about it is, imagine aliens that live on a planet where their atmosphere is much thicker than ours. And so the boundary between swimming in the ocean and swimming through the atmosphere is fuzzier, right? And so these aliens, as I imagine them, are like little bladders that can, pull in gas or extract gas or expel gas so they can go up and down. And, they figure out how to navigate their atmosphere. And so they're moving in 3 dimensions. And to them, navigation is an intuitive thing. They just sort of do it. They don't understand flight, the buoyancy. They're not figuring out those equations. They're just sort of like, the way a bird flies through the air. And it's not too hard to imagine a scenario where they then figure out how to, skip along the surface of their atmosphere, and then maybe even protect themselves from the dangers of space so that they can, navigate around the planet. Now they're inside their solar system. And if they happen to be so lucky as to live near a region of great curvature, maybe their star has a binary partner that's a black hole. And then they spend 1 million years like whizzing around that black hole and like intuiting the curvature of space in a way that's really alien to us, right? Yeah. It's really hard for people to imagine the curvature of space. And, the whole bowling ball and rubber sheet analogy doesn't help anyone and how pervasive that is. But if it was intuitive to them, maybe they could figure something out. Maybe they could figure out like, oh, here's what you have to do to make it tear or to connect it in new ways, and ... They're showing up on Earth and they don't really know what to do with the question, how does space-time work and how do you build this thing? They just do it. And they don't fundamentally understand. And so I'm not saying that's happening in our universe, but it's not too hard. I mean, I'm not a science fiction author, and I came up with this scenario that I think is not totally implausible, that you could intuit your way, stumble your way into fairly fancy technology without really knowing how it works, without being able to pass, for example, your GR class.
Well, and I love the idea that you could do space travel without a rocket or a spacesuit. I mean, we're pretty fragile, right? You and I couldn't survive very long in the desolate cold of interstellar space, but it's not actually that hard to imagine a biological organism that could both fling itself, from one planet to another and sort of shut its systems down and survive the trip until it landed somewhere. Maybe the reason why we don't notice the aliens is they're just taking a long time to travel from one star to another. I don't know.
Yeah, and tardigrades, for example, here on Earth are remarkably resilient to the atmosphere of space. And for all we know, they're building a colony on the moon right now after crash landing.
Yeah, I can tell. I don't know. Are we going to get to a point where rather than just saying, maybe it could be very different, how precise are we going to be able to get to be about here's the possible ways that aliens could be, even though we haven't met them yet?
I think it's useful work, digging into the structure of our physics and our philosophy and asking, hold on a second, did it have to be this way? Or is that just sort of like the easiest thing to do first and then we never came back to it? And there's like so many times in physics and like in my specific career that we've done that. We'd like, here's a really hard problem. We don't know how to solve it. We'll just sort of like, figure out a rough solution to get going. And then decades later, students are like, hold on a second. Why did you make this assumption? Couldn't we have done it this other way? And that opens up a whole new way of thinking and a whole new category of solutions. So in general, that's, I think, a very fruitful thing to do, is to like go back and examine your assumptions, because it creates new opportunities. And so I don't think we'll be able to get very precise, but I do think that digging into these details and asking these questions creates opportunities for us to learn, not just about ourselves, but also about the universe, to discover things that we otherwise overlooked. In the same way that like biologists now can look for life that uses arsenic, or life that is built in silicon, even here on Earth, right? It doesn't have to be aliens. But also when we go and explore other planets, now they can more broadly look for life. So I think that it can be very fruitful to help us solve unsolved problems, and it can help us to look for the aliens. I also just think it's fun. But in terms of like precision, I think there's no chance. Like there's no way you're going to be able to do this and then think, here's the way aliens have to be. I think we're so clueless from our one example. We'll be lucky if we anticipate the way aliens are at all, I think. And that's, that's the goal of the book, is to try a little bit to anticipate this before they show up.
I guess maybe I could imagine doing simulations that led to different, but it's I don't want to underplay the amount of simulating that would be required here to literally simulate the development of a species from primitive to technological in a computer, and just seeing how very different it could be. But maybe that's the kind of thing that, we're wasting a lot of power right now, running less interesting simulations than that. So
Yeah. Well, it's hard to know also how dependent it is on all of the details,
Right.
Is it chaotic and dependent on this ice age and this contraction of the population, or this migration or this experience or whatever, one super smart individual, or are there trends that emerge and it tends to happen in this way? And I mean, that's something you can pick out of simulation, but also, connects to another concept, which I really enjoy digging into, is like when trends emerge, right? When things emerge, when special sciences take over and you can write simpler laws and not just be linked to the chaotic details underneath.
Oh, this is good, because that's where I wanted to go. I think you've used the word emerge in two different senses there. Maybe there's emerge as something develops over time, but then there's also my favorite notion of emergence, where you have a way of describing the world with vastly incomplete information, but you can sort of approximate and coarse grain your way into a useful predictive theory. One big question in this whole field is, would aliens do it differently? Like, this is literally what philosophers worry about. Is there something in the nature of the physical world that either forces us or nudges us toward having certain emergent levels rather than other ones? So do you have a feeling about this?
I wish that I understood why emergence works at all. And the fact that I don't, why you can make chicken soup without knowing quantum gravity, right? Why you can sweep all these details under the rug, to me smells very fishy. And it suggests that there's something going on here we don't understand. And part of that could be human. It could be the way we're asking the questions, that we're interested in certain things. And so we tend to focus on them and pull out the simple stories because of our choices, because of things we're curious about. I wonder if the fact that we live on a planet and that we have rocks is what makes us think about like balls of stuff, and influences us all the way down to like, we should think about the universe in terms of tiny little rocks, right? In the sense that that's what we've been doing. Like, I'm a particle physicist, basically trying to explain the universe in terms of like the smallest bit of rock. And, I know we've made progress, and now it's like quantum fields and waves, et cetera. But I think that there is a sort of a basic element there in which we are perhaps imposing this structure on the universe rather than having it revealed to us. And, I was sort of shocked when I dug into the philosophical literature how confused everybody is about this question, because it is a hard one, right? And one of the challenges is that we can't calculate it. It's not like I know how to go from here is the chemistry of water to, okay, here are fluid dynamics equations, right? Nobody knows how to derive the Navier-Stokes equations from the details, even though it's happening in front of us all the time, right? And clearly it's happening, but why is it possible? We don't know. How do you get from here to there? There's so many details if you're going to run that simulation to get things right that we don't know how to do it, and so therefore we don't know why it's possible. And something that was really shocking to me when I dug into the literature is I always came with this assumption that things bubble up from the foundations. That I'm a particle physicist.
You're a particle physicist. I was going to say.
So I'm like, okay, I'm attracted to particle physics because I thought we're asking the deepest questions. And once we figure that out, everything else is some calculations and some details. That's this reductionist assumption that there is a firmament, and there are basic rules there that we're trying to reveal. And once we figure those out, everything else stands on top of it. But there's lots of philosophers out there arguing that maybe all the different sciences are on their own as fundamental, that like things don't bubble up from above. Maybe there's interplay from different levels that control each other. And, of course, this connects to questions of consciousness, right? How does the mind emerge? And is the mind physical and therefore, a product of particle physics and quantum fields? Or is there something else going on and the mind controls the physics? And there's all sorts of crazy questions. And it's a swamp of confusion. And so that tells me that there's a lot of opportunities there for our humanity to creep into our answers. But you're a quantum field theorist and expert in this area. What is your sense? Like, why is it that we do physics at the weak scale and the Higgs boson has this number? And what does that tell us about the structure of these theories and whether they're human or universal?
I've actually been tending in the direction that they're pretty universal, to be honest, the more I think about it, because I do think that the existence of a sensible emergent description at all is kind of miraculous, right?
Yeah.
It's true that maybe we don't know some details about deriving Navier-Stokes from particle dynamics, but it's kind of obvious what we mean by the definitions, right? By pressure and velocity and things like that. And those involve very, very specific ways of coarse grading the underlying information to the macroscopic information. If you coarse grained in a different way, you wouldn't get good equations, right? Locality and things like that play a big role. So once you get up to economics or society, then maybe it's a lot messier, or consciousness or whatever. But I think that once again, just like the telepathy examples and whatever, the basic structure of physics does constrain our imaginations maybe more than we think. I mean, that's where I am right now, but I think it's a super interesting question. I don't know all the final answers.
I mean, there are assumptions that we make there, like we want a theory that's renormalizable, right? And when I see my colleagues write down potential new theories, they're very highly constrained in the structures of theories they can build because they come with these assumptions. You want causality, you want locality, you want renormalizability. But, those are the structures of the theories that we've made work. Right? That doesn't mean necessarily that that's how the universe works, right? That fundamentally there isn't another explanation that's simpler or better or doesn't come with all these sort of mathematical headaches. And in that other mathematical structure, it might be that, things are structured differently. I'm like very speculating wildly here, but it feels to me like, these things smell like assumptions. We could go back and take a different path if we needed to, or it's possible that, in another Earth, somebody could have made a different set of assumptions. I mean, if I told you to write quantum field theories down and not make some of those assumptions, wouldn't you have more flexibility?
Yeah, absolutely. I mean, one of my research projects right now is trying to figure out what would the experimental consequences be of being a little bit non-local in your quantum field theory. And guess what? It's very hard to make it work. Like, you don't want it to break right away. Just like Lorentz invariance is something that is very crucial, causality and so forth. But I guess that's what makes me think that the aliens would also discover the Navier-Stokes equations. I actually, I like examples where everything is perfectly understood. So my favorite example is center of mass motion of planets, right? Where you have 10 to the 50th atoms in a planet. You don't need to know what all those atoms are doing to predict how the planet moves around the sun. And that's miraculous and special. And it's what Dan Dennett called a real pattern in the universe. So there's different layers of real patterns, but discovering them all is something I'm suspecting the aliens and we will have more overlap in our pattern discovery than we might have guessed.
Yeah, it's very tempting to say, like, look, of course the aliens are going to notice planets, right? Because planets are a thing. I'm not imagining the planet. And it's true, planets are a thing, but like the more you dig into it, you're like, well, how do you define a planet?
Yeah.
Okay, well, astronomers have been arguing about that, and the definition is not that crisp. You know, it's like they've had to reverse engineer this definition so that we have something we can call a planet that feels special. Right? Because otherwise the solar system's filled with planets and they're all different sizes and there's a spectrum. And basically the solar system is a bunch of stuff out there, chunks of stuff of varying sizes. And I encourage you to Google the map of like how they define things in the solar system. It's a mess. They got centaurs, they got trans-Newtonian objects. It's overlapping and nonsensical. And it comes out of our desire to make planets special. Or think about like anytime you see a depiction of the solar system, is it ever to scale? Oh no. No. It's like zoomed in on the planets in this ridiculous way. And like maybe aliens who again, develop in the atmosphere of a sun would be like, y'all are weird about planets. And so, yeah, planets are a thing, but so are dwarf planets. And like the boundaries we created, those feel human. The dotted lines we draw around these things, when it's really a spectrum of phenomena, makes me think that we're, in some way biased to thinking in this direction. But maybe the aliens have figured out complexity, and they know how to go from real pattern to real pattern, and they understand why this happens. It would be awesome if they did.
It would be awesome, but I absolutely take the point. You're completely correct that we should always be trying to check our biases when it comes to these questions. So it's a very, very important exercise. So,
and for me, like. This book is not making the argument that I personally believe. I would love if aliens came and launched us forward in the direction we're moving. To me, this book is that it's an exercise in checking my biases. It's like, what's the strongest argument I can make against this feeling that physicists have that aliens will do Lagrangians, essentially? And so it's a really fun exploration.
They're going to come down and write down a partition function, and we're going to be off to the races. But okay, at the end of the podcast, we've asked you all the easy questions. So now I just have one more big hard question for you. So let's go from is to ought. We talked about the aliens and their math and their language and their science. Does going through this exercise inform how we might think of alien values or ethics or morality? Will they be nice to us, the aliens, you think? Or is that something where we should also just be super duper open-minded, that maybe we're food to them, or they don't even notice we exist?
Yeah, I think that's a whole fascinating category of questions. What's it going to be like when they show up? How do we even communicate to them that we want to talk about this, or should we? Like, if you had to put a bunch of people in line to talk to the aliens, should physicists be in the top 5, the top 10? Like, I don't personally know a lot of physicists with social skills who I would trust in that scenario to not get us nuked from orbit. But how do you even start talking to them? And this is the thing I find frustrating in a lot of those science fiction novels, is that they sort of yada yada over a lot of these crucial details of how you start figuring that out together. Even books like Arrival, which was very creative in thinking about different kinds of aliens and their relationship with time, or Project Hail Mary, which is very creative about different kinds of aliens and the way they might experience the universe. There's a lot of this dotting over this crucial step of like, how do we sit down and figure out what we have important together? And in the end, that's part of what this book is about, is like, what do we have in common with the aliens in terms of wanting to understand the universe? Do they want to understand the universe? And if they do, if they also are curious about how this works, then I suspect we're going to have a lot in common, and they're going to want to talk to us. They're going to be curious about what we figured out. And maybe we have a couple of juicy tidbits we could share with the aliens and blow their minds, right? We expect they're probably more advanced than us, but they could have followed a different path, and maybe they didn't figure out group theory, and that could be very useful to them. So I think they'll have something to offer. The chances that aliens come and just eat us, it seems to me like it's a fun thing for a science fiction show, but in reality, the universe is so vast and so filled with resources, I can't imagine why aliens would bother to come and visit us if they're not interested in us in some level. Right? Because if they want hydrogen, there's plenty in the solar system. They could have some, and it wouldn't even bother us. If they want heavy metals, like whatever, if they want water, the universe is so filled with resources. I can't imagine that they're going to come and just, enslave us in some sense. So if they have something in common with us, then I think we're going to have an interesting conversation.
I do think that I was joking about them eating us, and I do think that you're completely correct. Like, we're not the best place to mine for resources, really. But I've still also been mostly of the opinion that we should not advertise our existence to the wider alien community too readily, because even if there's just a 5% chance that they eliminate us for some reason that we don't know, like if we are going to check our biases and think we don't know what alien math is or alien science is, we should certainly do the same for alien ethics and morality.
Mm-hmm. But let me put a thought experiment to you. Like, how much would you risk to learn the secrets of the universe? Say there's some alien species flying by and they're a billion years advanced and they have all the answers. I mean, don't you want to know? Like, wouldn't you be able to take a little bit of a risk in order to get those answers? Personally, for me, like, I would be frustrated to die not understanding the way the universe works. And so I'd be willing to get blasted from orbit if at first they download, their theory of everything.
I might be willing to do that for myself, but for the entire rest of life on Earth, I might feel like I don't have the right to make that choice. But it's something we got to think about. It like, we're getting better at detecting other worlds, maybe even traveling to them on the time scale of, the next 10,000 years. These are not just going to be hypothetical questions, perhaps. So
and the folks at SETI, for example, have done a lot of careful thinking about how we might communicate with aliens, who gets to speak for Earth, how do you sort of form a consensus. This is something I've been impressed by, how deeply they've dug into these questions and the moral and ethical questions connected to them. Then, of course, there are people just broadcasting into space anyway.
Right.
So...
And also the chances that the people at SETI's careful considerations are actually going to be listened to by the powers that be when the event happens may be smaller than we might think. But anyway, super good things to think about here. Checking our biases is always a good idea. And Daniel Whiteson, thanks very much for being on the Mindscape podcast.
Thank you very much.